Perfect. So, Assalamu alaikum, everyone. Welcome to the fourth tutorial for probability. My name is Munif Rizvi. I hope all of you are doing well. So, um, like last time, I've tried to find questions from the book based on the topics that we're covering so far. In class right now, we've covered like last week's tutorial focused just on conditional probability, but the thing is, conditional probability is a very vast topic, and in terms of like the applications you might need it for later on. So this week focused on more the use of conditional probability with independent events. So some of the things that we will be covering in the questions today, you might feel that some of them have been covered in last week's tutorial, but they are with respect to independence cases in particular. So I would encourage as much involvement as I can from all of you, because sort of this week's tutorial will be a lot on like your conceptual knowledge on a lot of stuff. So I'll give you guys 10 seconds to read the question and then I'll start. So wait, so the first question says, if two fair dice is a roll, what is the conditional probability that the first one lands on 6, given that the sum of the dice is I? So what that basically implies that we essentially need to find where basically I is the sum of all values that can be taken if you sum two dices in this case. So just putting it out there, can anyone tell me what are the ranges of values that I can take? Note how it has to be summed up by 6, right? So it can be 2 to 12. Perfect.
7 to 12.
Perfect. Absolutely perfect. So it has to be between 7 to 12. Note how in this case, a lot of people might confuse, if I write 6 given 7, they might confuse it with something else. So basically 6 probably it basically implies probability of you getting a 6 given that the sum is 7. Okay, so we first covered this bit. Now using the formula of conditional probability, if I want to expand this will basically be 6 and I divided by the probability of just I. Now the thing is, can anyone tell me what the entire sample space is in this question? Not particularly to what the question is asking us, like the last statement, but rather the whole experiment. Can anyone tell me a sort of possibility of values that I can have, or rather the total number of the total number of values that can be taken in this sample set? So the thing that we need to note is, essentially our experiment is basically we're rolling two dice and we need to see what are the sum of values or what are the range of values that we can have, because our both dice have 6 values. The total number of possibility values that we can have are 36, right? So the sample set contains 36 values, like 1 1 1 2, similarly 2 1 2 2 6 5 6 6, etc. So we know for a fact that our sample set has sort of 36 values. Now, if I ask you what is the probability of you getting a 6 and a sum 7, essentially what value is that in terms of our sample set? Like if I say probability of you getting a 6, and I'm going to change the color just to be sure, and a 7, essentially what is that value? In our sample set, it basically means you getting a 6 and a 1, right? So what's the probability for that? 1 upon 36, right? Absolutely. It's 1 upon 36. So one thing I figured out is that for one possible value, it can be 1 upon 36. Now, my next question to you is I will just focus on this pi bit right now. So pi can be either 7, 8, 9, right? And it goes till 12. So can you tell me what's the probability of you getting a sum of 7? It's essentially um, like what you did before, right? Yep. So the thing is, for you to get a probability of sum of 7, you need to list down all possible values in the sample set, the 36-point sample set that you had that can give you a sum of 7. So one value could be 1, 6, right? Another value could be what, 2, 5. Then another one this is just for P7, just by the way, just write it here. And note this is the sum. So 3, 4, and likewise could also be 4, 3, 5, 2, and 6, 1. So in our sample set, for you to get a sum of 7, it can be 6 upon 36, because these are 6 values that we have here out of a total sample set of 36 possible combinations of values that you can get, right? So likewise, just how we did for probability of the sum being 7, we have to do it for 8, 9, 10, and 11, 12. I would encourage as much participation as I can get. So can anyone tell me what will be the sort of probability for the sum being 8, 9, 10, 11, 12? Let's first start with 8. Or can, if not the probability, just tell me what the sample points can be.
It could be 2 and 6.
Perfect.
Then 3 and 5.
Perfect.
And 4 and 4.
Yeah.
And 5, 3 and 6, 2.
5, 3, and 6. Thank you again. So this will be 5 upon 36. I'll do it for P9. 3, 6, 4, 5, 5, 4, and 6, 4. No, wait. Yes, I think I know. 6, 3. 6, 3. Do you guys see a pattern here? For every iteration of the sum, it's sort of decreasing, right? So if I want to put in the effort, and if assuming I have the time for me to calculate everything, I can list down all the possible values and then sort of add it, right? But now I can tell that there is a pattern, and if because you will have quizzes, you should run short in time. So I will take this opportunity and just write this will be 3 upon 36. 11 will be 2 upon 36, and P12 will be, yeah, just one possibility, right? Now, the only thing we've done so far is that we figured out what are the possible values that this can have, like separately, right? And we figured out what's the probability of you getting a 6 and and a sum of 7, which basically implies you getting a 6 and a 1. Likewise, you getting a 6 and 8 would imply you actually in reality getting a 6 and 2, which would imply that you only have one sample point. Basically, what I'm trying to say is that regardless of whatever some value I take for I, this value can only be 1 upon 36, because you have 36 sample points and only one possible value that can accommodate that condition, that and condition, right? The end goal I want you to have in this question is, in hindsight, it's not a difficult question. But the thing is, if you know your axioms of probability, or you know if your logic is sound, you can do this question in 2 minutes particularly, right? Instead of like you writing down all the sample points that I have, if you know what each value of pi represents, or what p of 6 and I represents, you can do this question very quickly. And this is basically a response to some of the feedback that we've gotten, that some of the quizzes are very time consuming. I agree, the pressure is there, 100% is there. I've been in that position and even I've stumbled. But with that being said, the beauty of probability is that if your logic is sound, you will find ways to go around the question and you can do it very quickly. So essentially, if you want, I can solve this, like list down all the values, but essentially what will happen is 6 given 7 would basically imply 1 upon 36 divided by what was the value that we got here, that was 6 upon 36, and that is 1 upon 6. 6, excuse me for my writing, 6 given 8 would imply 1 upon 36 divided by 5 upon 36. I see another pattern. 6 5 4 3 2 1 का पैटर्न हमने पहले बताया था for this sum, right? और ऊपर की value is constant at 1 upon 36. So essentially this will be 1 upon 5. The 6 given 9 will be 1 upon 4. The 7 given 9 will be 1 upon, sorry, notation गलत है. 6 given 10 will be 1 upon 3, and this will go on. Now, just to confirm, if मिसाल के तौर पे मैंने टाइम नहीं था, मैंने लॉजिकली ये कर दिया, I just want to make sense of what I've done, whether it makes sense to me logically or not. Based on the sort of the sequence I made, right? This would basically imply that 6 given 12 will be 1. Does that make sense to me? So basically, what the question is saying, what the statement is saying, what is the probability that I got a 6 given? What is the probability that I rolled a 6 given that the sum is 12? Naturally, अगर sum 12 होगा तो 6 और 6 ही हो सकता है, कोई और अलग value नहीं हो सकती. So yeah, it has to be 1, क्योंकि कोई और value हो ही नहीं सकती, right? Like कोई और value नहीं हो सकती जो 6 की जगह ले सकती है. So in essence, the probability will be 1. ठीक है. So logic is clear. I'm done with the question. Cool. So, any questions? Because I think that was the question in particular. Also, if you guys think that I'm going a bit slow, please do let me know. I'll sort of pick up the pace. So the next question, I'll give you guys like 10 seconds to read it. Okay. So if you're done reading the question, I'm gonna sort of write the English bit into prob statements, like make them into events and then see what the probabilities come out to be. An ectopic pregnancy, I don't, if it's ectopic, I don't know. Ectopic pregnancy is twice as likely to develop when the pregnant woman is a smoker. So ye is the probability that a person is ectopic, and given that the person is a smoker, it's twice when, okay, when she's a non-smoker. Okay, so basically what this statement basically implies is the, any doubts with this question? Sorry, with the statement? Because they're saying it's twice as likely to develop when the pregnant woman is a smoker as it is when she is a non-smoker. So twice that probability. If 32% of women of childbearing age are smokers, so okay, what percentage of women have ectopic pregnant genes are smokers? So the question statement is essentially S given E. This is what I have to find out. So in my eyes, it's a very straightforward question. It's total probability. So I'm going to rush through this and let me know if you have any problems. So I'm going to expand this using conditional probability formula. Now using total probability, I'm going to expand this as well. And this will now become, okay, so one hack I have for total probability from is that I don't remember the formula, but I know if I have to expand this using total probability, the S and E terms ulte ho jate hain. So this becomes E and S, and the right term is also added on the right, so PS, and the entire statement goes to the denominator as well. That's how it's a jugaad essentially. So I'm going to write the entire statement like this, plus इसका complement या इसकी additional argument जो होती है. This is how in my mind I remember total probability formulas, just in case I forget. So essentially the question has already given us all the details that we need. Now essentially, what changes do I have to make? Because based on this, I feel I just know PS. Like it's as a tangible value, I just know PS, that's 0.32. But I know the relation that the E given S is twice E given S complement. So I'm going to substitute that in. So this will be 0.32 into PS. Sorry, P. बट उसूली तौर पे हाफ होना चाहिए ना, ठीक है, हाफ कर दूंगा. Plus 2 times 0.68 into E given S. Now, one thing I can do is that all of these terms cancel out, right? So if they cancel out, essentially all I have left is 0.32, 1.32 plus 2 times 0.68, and that is 0.1904. It's a very basic question. I just wanted to go over total probability one more time. So if there are any questions, please ask away, otherwise I'll move on. Okay. So I'm assuming there are no questions. So I'll move on to the third question. A family has J children with probability Pj, where P1 is okay. So they've given me the probability of a family having a total number of children. A child from this family is chosen, given that the child is the eldest. So E, I'm going to define E as an event where basically E implies that the child chosen is the eldest. And the conditional probability that they have only one child. Can anyone, so if I define an event that like this person is chosen, so essentially what I'm trying to say is CI basically implies the total number of children that the family has, and like where I can be between from 1 till 4. If I say find the conditional probability that the family has only one child, given that the child is the eldest child, can I say that essentially what the question is asking me is this, based on the events I've described? If there are no issues with this, I'll go on. So CI basically is defined as the number of children in a family, and E is the event that the child chosen is the eldest. So if they're saying find the conditional probability that the family has only one child, all I'm gonna do is basically this, right? C given I. So I'm going to expand this using the same total probability concepts. Note how this may seem familiar to you because to an extent it is. I will expand the denominator using a total probability again. C1. Note how this will go. I'm not going to write the entire thing, but this will go to like C4. Okay, that is one thing I just needed to tell you. And based on the values that they've sort of given me in the question, P P1 is equals to 0.1 basically implies. Okay, so can anyone tell me what will be the probabilities for like the denominator bit here? Can anyone tell me what's probability of E given C1? E given C1 basically implies what's the probability that the child chosen is the eldest, given that you only have one child. Essentially, it's one. Like the probability will just be one because well, एक ही बच्चा है, तो naturally it's the eldest. Naturally. Here, so PC1 is already given in the question, and that was 0.1. Likewise, what's the probability that the child is the eldest, given that there are two children in the family? Half. And what's the probability that they've given me? 0.25. In this fashion, I'm going to fill the entire table. This is just for the denominator, just by the way. Right, so I filled the denominator, and note how the first term that we wrote in the denominator is basically the term that we wrote upper as well. So this will be 0.1 to 1, this term particularly. So I'm done with part A. Okay. For your reference, the value in the denominator is essentially, I think 0.4167. But this will come in handy later. So now part B says, find the, so given that the child is the eldest in the family, what's the probability that, find the conditional probability that the family has 4 children? Do you think we have to do something different in this question? In this part particularly, do you think we have to do something more, or is it very straightforward? Essentially, do we have to just directly input in the values, or do we have to do any additional work? And that is what I want to ask you. Wait, I got a private chat. Yeah, absolutely. So, one good person who is in the chat just said in a private message that essentially we don't have to do any work. The reason being that if you expand this, PE will still be the same term. We calculated before it's 0.4167. So now PE given C4 is basically what? Eldest given 4 children, that's 1 upon 4. What's probability of C4? That's 0.3. So it's essentially 1 upon 4 into 0.3 divided by 0.4167. So now the reason why now, with the benefit of hindsight, this question may seem easy, but you would be surprised to know that this question has been used before in a previous component, in a previous term, and a lot of people got this question wrong. Just based on the fact that people would overcomplicate it based on thinking that because there are 4 children, we have more permutations. Cool. So although this may seem easy now, please be wary that a lot of people got it wrong. That's the only thing I wanted to sort of tell you. Are there any questions? If not, I'll move ahead. Also, this tutorial has 5 questions in total, in which the last one is basically, it's not even a question, it's just a discussion I want to have with you guys pertaining to that question. So we'll be done with this tutorial pretty quickly. So I'll let you guys read the 4th question. So die A has 4 red and 2 white, while die B has. This is a fun question though. When I say fun, I mean it's long. So I would love it if you guys can sort of do this question with me as well. 2 red and 4 white. A fair coin is flipped once. If it lands on heads, the game continues with die A. If it lands on tails, then die B is to be used. ठीक है. Show that the probability of red at any throw is white लग रहा है मुझे, is 1/2. ठीक है. So how I'm gonna prove this? So essentially what they're asking me is to calculate P red. Now the thing is, this can go on for a long time, right? It can take like 1 throw, 2 throw, 3 throws for you to get a red, but we just need to find out, regardless of how many number of throws you have a probability of 1/2 for all chances of you getting a red. So I know from the formula of total probability, first, that an expression like this is usually the denominator, and I can expand this, right? I know for a fact that I can expand this, but before I reach that point, I need to first make events that can coincide with this sort of denominator term in my mind. So essentially what they're saying is, अगर मेरा die A आता है या B आता है coin toss पे, तो उसके आपसे what's the probability of you getting a red? So I can divide this as Ri given A as a term and Ri given B. What I mean by that is, regardless of the number of throws of the coin toss, right? बेशक वो first coin toss हो या second coin toss हो या third coin toss हो, there is a probability that with that I can get a red. Like it can land on the red die depending on what the coin toss result is. Okay, so these are the two parameters that I have. Now, how do I write this in terms of sort of total probability? Because I've written these two terms, I know for a fact that total probability ka term sort of also gives me the liberty to write any term in this fashion. Am I wrong? So I've done this. Now, I've written this term. Now I have to sort of figure out what are these values, what do these values can be. So if it lands on die A, or like the coin cost tells me that like die A pe jayega, so then what is the probability of me getting a red? There's 6 faces, so this is 4/6. Coin toss hai, what's the probability of me getting like it landing on A? Basically the coin toss giving me a head, that's 1/2. Likewise, this will be 2 red 4, so that's 2/6, and that is 1/2. So essentially what I'm trying to say is, ये जो given term है, this conditional term, अगर मिसाल के तौर पे थर्ड कॉइन टॉस या फोर्थ कॉइन टॉस में भी अगर मेरा ए आता है और उस ए में भी इट लैंड्स ऑन द रेड डाई, तो उससे में प्रोबेबिलिटी फर्क नहीं पड़ेगी. एसेंशियली इट्स एन इंडिपेंडेंट इवेंट, एंड दैट इज व्हाट आई वांट टू शो यू कि इट डजंट मैटर मैं कितनी दफा इसको रन कर रहा हूं, बिकॉज दिस इज एन इंडिपेंडेंट इवेंट, regardless of the number of coin tosses I throw, the probability will remain the same. Okay, so now adding these two probabilities, 4/6, that's 2/3, into 1/2, that's 1/3, 1/3 into 1/6, oh yeah, that's 1/2. So essentially the only lingo I need to write is, because the probability of you getting I given is independent of the number of coin tosses I have. This gives me the liberty that Ri, regardless of the value of I, the probability will still be 4/6, right? And the coin tosses, we know for a fact it will be half-half. उन्होंने कोई बताया नहीं कि it's like unbiased or something. It's a fair coin toss. So that's how I can just prove this. It's essential for me to write this statement when I'm proving this. Okay, that because this is independent, that's why I can prove this regardless of whatever number of coin tosses I have. Now, part B. hold on. I have 9 minutes left remaining in this meeting. So I would ask you to, once this meeting ends, I would request you guys to join it in like 30 seconds. I'll start the call again using the same link. So part B basically says, if the first two throws results in red, what is the probability of red at the third throw? Okay. Red at the third throw given the first two. So this is what the question is saying. Now, using the notions of, I will write two approaches here. Instantly in my mind, the first thing I can think of is I am going to expand this using the formula of conditional probability. This will be R1, R2. But essentially, I don't have enough information for this. I don't know what's the probability of you getting R1 and R2 and R3. It has to be the statements that we know were given to the respect of the die throw that we had. This is incomplete information for all its respect. So I can't use conditional probability. But there is one thing that we learned in the in the last lecture that we covered called the Laplace's rule of successive independent terms. What this basically implies, I'm going to write what. So firstly, the Laplace is, as you have a question, ask away.
जी सर यहाँ पे हम ये प्रोबेबिलिटी ऑफ R1 R2 R3 कैसे कैलकुलेट करेंगे, मतलब वो क्यों नहीं कर रहे?
वो अब कैसे कर सकते हैं, क्योंकि हमें नहीं पता कि ये कॉइन टॉस क्या डाई ए में गया है या डाई बी में गया है. ये इनकम्प्लीट इंफॉर्मेशन है.
सही, मतलब अगर हमें पता हो कि R1 इवेंट में क्या है, R2 में क्या है, तो फिर अगर हमने उसकी कैलकुलेट करनी हो, हमने उसके कॉमन जो एलिमेंट्स होते तीनों में,
जी जी,
उनकी प्रोबेबिलिटी लिखनी है.
हाँ एब्सोल्युटली कर सकते हैं, लेकिन इसमें आपको ये नहीं पता कि पहले कॉइन टॉस में ए आ रहा है या बी आ रहा है या दूसरे कॉइन टॉस में बी आ रहा है ए आ रहा है. इट्स अ वेरी लॉन्ग कंप्यूटेशन एज अ रिजल्ट ऑफ दिस. आई थिंक हो भी सकता है जो आप कह रहे हैं, बट आई थिंक दैट मेथड विल रिक्वायर अ लॉट ऑफ टाइम. And I'm at this point, my focus in this tutorial is to look for ways that I can do things quickly, if that makes sense. So,
thank you.
You're welcome. So in the Laplace rule of successive terms, what that basically implies, if I say that if A and B are conditionally independent on C, then I can write A and B given C as A given C multiplied by B given C. This is what the Laplace rule of successive terms imply. That if A and B are conditionally independent on certain event B, C, then I can separate these two terms. Note how these two terms are independent. I don't care what I got in the first coin toss, because at the end of the day, my probability of me getting a red in the second coin toss will not be affected by what I got before it. So essentially, these are conditionally independent, right, on the event RQ. So based on this, I am going to rewrite this term as ये खाली एक केस हो गया जब ये ए था. नोट हाउ ये एक्सपैंड हुआ, क्योंकि आपको ए का भी कंसीडर करना है, बी का भी कंसीडर करना है. अच्छा, just by the way, this is the term that we got from conditional probability. याद है मैंने बोला था अभी थोड़ी देर पहले कि it could have been A or B in the regardless of the coin toss. अभी मैंने इसको total probability के फॉर्मूला से expand किया into the possibility that it could have had, like of A and B. And this will be divided नोट हाउ मैंने ये दो टर्म्स दी थी और इनको पहले कंडीशनल प्रोबेबिलिटी के टोटल प्रोबेबिलिटी के फॉर्मूले से एक्सपैंड किया. Now I'm going to use the conditional independence. The only reason I've done this is because I know this is not getting me anywhere. So I've purposely expanded this to this point. Now I'm going to use the Laplace's rule, right? Now, in this case, with in particular, how I can use this is that as R1, R2, R3 are conditionally independent on A, as well as R1, R2, R3 are conditionally independent on B, I can separate this in this form. Yeah, multiplied by PA, because we can't forget this. ये अलग वाली term है. Likewise, we'll do the same for B. Now, I'm going to expand the denominator as well, but note how यहाँ पे खाली दो terms है. R2. ये A. R1 given B. R2 given B. This is just the property of U getting a B. Now, in my mind, I feel like I have all the values I need to particularly like solve this question. What is the probability of me getting red on like the red given that it landed on A? Let me just see the number of the red in, say, that's 4 upon 6, 2 upon 3. So that's 2 upon 3. This will also be 2 upon 3. This will also be 2 upon 3. Okay, we're just concerned with A. What's the probability of getting A? It was a coin toss, so that's 1 upon 2. Yahan pe there were 2 red, 4 black, I'm assuming. So that's 1 upon 3, 1 upon 3, 1 upon 3, 1 upon 2. Likewise here, 2 upon 3, 2 upon 3, 1 upon 2. Red, yeah, that's 1 upon 3, 1 upon 3, and 1 upon 2. So essentially, the entire term is basically 2 upon 3 cube into half plus 1 upon 3 cube half divided by 2 upon 3 square half and plus 1 upon 3 square half. Any questions? Izaz, your hand is raised. Do you have a question?
No, sorry, it was from the goal.
No, it's okay. It's all good. So essentially, though मेरे दिमाग में था कि it would have been a big working, I've condensed it particularly. Also, the meeting is ending in less than a minute, so I'm ending the meeting now. Please join in 30 seconds. So, welcome back, everyone. That was awkward. With that being said, what have we covered up till now? We've shown that we've basically solved this expression जो वैसे conditional probability से expand नहीं हो रहा था, but using the notions of Laplace's rule of successive terms, we're using that same sort of term of conditional probability and sort of changed it or maneuvered it in a way that we could have used Laplace's rule of successive events or terms. Okay, note how for that to be the case, your successive events, like in this case R1, R2, R3, need to be conditionally independent on a certain event, in this case A or B. Okay, so these are the parameters that you can check, that you have to check before you use this. Otherwise, if those successive terms are not conditionally independent, please do not convert this into Laplace's rule. Like you have three those events might not be successive particularly, or they might be related to another one. Like in the case of like you picking marbles from like a bag, if agar if this is without replacement, then we can't use successive term because the probability of your second term depends on what you got in the first term, right? So that is what I needed to emphasize in this case in particular. So I'm not going to get into what the answer here should be, but like the working here. like what the working that we're getting. So part B, if the first two throws results in red, what is the probability of red at so part C is if red turns up at the first two throws, what is the probability that it is die A that is being used? So just to confirm what they're saying, can anyone tell me what's the conditional term that we're supposed to write there? Like what the question is asking us for? I have it written down, but just want your feedback as well. Like, what's the conditional term that this question is asking us to do? I state it again. If red turns up at the first two throws, what is the probability that it is die A that is being used?
Probability of A given क्या है red R1 R2.
Perfect. Very good. So it's probability of A given R1 and R2. So I have successfully proven before that we can use Laplace's rule of successive terms. And in this case, I'm going to use the same thing because I see R1 and R2 are there together. So I can use this principle. So expanding this with the respective total probability. अभी तो खाली मैं conditional probability का formula use कर रहा हूँ. Given A. You know how first the term is A and R1, R2, and then you expand that as well, and then you get this term. I've just directly written it here for anyone who's confused. And denominator में we will get R1, R2. And ठीक है, R1, R2 हमारे लिए फिर भी expand करना आसान है, या strenuous नहीं है, क्योंकि we just have two terms, right? So I can, पिछले वाले केस में expanding it would have taken me like lot of terms. इसमें it's pretty easy क्योंकि R1 and R2 basically implies you getting red in A, red twice in A, or red twice in B. So this will be essentially 2 upon 3 square, 1 upon 2, that's 1 upon 3 square, into 1 upon 2. Also, I think I remember, let me just confirm, we can just use the term that we got here. So essentially it's this term. I can use whatever denominator value I got from here and I can use it here. तो मैंने अलग से expand कर दिया था in my mind, but these questions were linked. So apparently the denominator that you got in part B, you could have used the same in part C as well. But this also goes to show us that अगर terms come हो, you can just sort of in your mind calculate it as well. So ऊपर वाली term क्या है? R1, R2 given A. So दोनों बारियों में A पे आया है. So that's 2 upon 3 square, 1 upon 2, and whatever the denominator term was that we got here. I'm going to write this as X. So, yep, that's essentially we're done. Okay. So we're done with this. Are there any questions?
Yes, sir.
जी इजाज़.
सर ये आप थोड़ा रिपीट कर सकते हैं, लेकिन मेथड की तो मुझे समझ आ रही है, लेकिन कहाँ पे लेप्लास हमने यूज करना है,
अच्छा,
कहाँ पे नहीं करना.
ठीक है. Laplace's rules of successive terms आपको essentially ये तरीका बता देती है कि if you have successive terms जो आसपास आ रही हैं, but they're conditionally independent on another event. If those successive terms are conditionally independent on another event, then you can use Laplace's terms, successive terms. जैसे जो मैंने आपको मार्बल वाली एग्जांपल दी थी, अगर यही क्वेश्चन होता, but instead of die it was you had to pick marbles up. मिसाल के तौर पे अगर आपका heads आया, then you pick marbles from A, अगर tails आया you pick marbles from B, और ये भी हो सकता था कि अगर heads आया you pick it from the same bag, या कोई different order में आपका bag change होता. और assuming without replacement है, like you don't put the marble back in the bag, तब इस केस ऑफ सक्सेस Laplace रूल नहीं अप्लाई कर सकते, because the probability of what you got in the previous terms matters in like the fourth term, for example. अगर मेरे पास 4 marbles हैं और मेरी छठी बारी में 4 marbles चले गए तो उसकी कोई probability बची नहीं, ठीक है. In this case it doesn't matter कि मेरी क्या 6 पिछली terms आ रही हैं, because ना कोई without replacement हो रही है, तो बस एक die roll हो रहा है. Die roll उसूली तौर पे doesn't matter on what I got in the previous die roll. तो उस केस में, and based on the fact that there was a third event in this being the coin toss as in कि deciding कौन से die में roll हुआ है, that is dependent on the other event जो मेरा coin toss है. इन केसेस में जब आपके ये सेपरेट केसेस, 2 सेपरेट इवेंट्स हो ना, तब आप लाप्लास रूल लगाते हैं, ठीक है. आई होप दैट मेड सेंस.
Yes, thank you.
Okay. Now, essentially we're done with this tutorial because I had to focus more on conceptual knowledge in this, but I added another question because I want your feedback on one thing. So let me zoom out a bit. Yeah. So can anyone tell me, so part A and B are easy, but it's just a discussion that I want to have with you in part C is what I'm aiming for here. So independent flips of a coin that lands on head with probability P are made. So like heads, so heads pair, you have a probability of P, so tails pair it's 1 minus P. What is the probability that the first 4 outcomes are head? So that I'm assuming that's P4, right? Part B ka kya hoga? Can anyone tell me? Like we're done with part A, legitimately, it's just this. But can anyone tell me what's the probability for part B?
P power 3 or 1 minus P power 1.
1 minus P into P to the power 3. Perfect. Now, the discussion I wanted to have with you is, assuming you have this question, just by the way, this question is from the book. So matlab, it is a question that can be tested so I can test you on this. I doubt you will, because this is more conceptual than sort of quantitative, but this is a discussion that we need to have. What is the probability that the pattern THHH occurs before the pattern 4H? Is there a thought process or is there a working that you feel like you need to do, or is it just a theoretical answer? I'll give you guys like 10 seconds. Essentially, this question should not be very important, just based on the fact that it's not a very quantitative question, it's a very theoretical question. But I feel like it's important to cover this as well.
सर ये कॉमन इंट्यूशन से भी हो जाती है, मतलब चारों जो हेड्स हैं
जी, तो आप इसका एक्चुअली वन लाइनर आंसर है, बट आई जस्ट वांटेड टू आस्क यू वो क्या कॉम्बिनेट्रिक्स होती हैं? So the reason why I've put this question here is because essentially what they're asking you for is not like a list of possible values, that conditions that you can have. In this case, the question is only saying, what is the probability that the pattern THHH occurs before the pattern HHHH? Iska converse kya hota? Like iska complement statement kya hoti? That the pattern 4H's occur before THHH, right? So in hindsight, if I just want to find out what's the probability for that condition not happening first, in this case in particular, what is the probability of this condition not happening at all? तो वो मैं किस अंदाज से लिख सकता हूँ? Like पहले ये आता है फिर ये आता है. The trick is, these are independent events. So in hindsight, if I have to find out कि ये बस पहले ना आए, it doesn't matter what I get here, उसूली तौर पे, right? If I just have to make sure that 4 H's don't come up before THHH, assuming these are the first 4 terms, right? Or like the middle terms or ये end की terms है, all I have to take care of right now is make sure that this doesn't come up before, right? Because these are independent events. So in hindsight, what we calculated in part A, that is our answer, because essentially for this not to happen, it should be 1 minus p to the power 4. In terms of a verbal understanding, the pattern 4h's can only occur before THHH if the first 4 coin flips come up as heads. Hence why PTHHH occurs before HHHH only if you subtract 1 minus the probability of you getting 4 H's, as they are independent events. Interesting. Okay? So that's the only thing I wanted to tell you guys, that just think of how independent events are useful in conditional probability, and how can you structure questions. Just simple rearranging questions can be easy if you know how independent events work. Okay, like a coin toss is the atypical example of an independent event, because it doesn't matter what I got in the previous coin toss. Or like a dice roll, for example, it doesn't matter what I got in the previous dice roll, right? So this is a discussion I wanted to have with you guys. Okay. So with that being said, we're pretty much done with the tutorial. If there are any questions, you guys are more than welcome to stay back. If not, I will end this recording in like a minute.
Excuse me, sir.
Ji, ji.
Sir, I have
let me just pause the record, stop the record.